26 degrees, and the way that this is applied is if you've got a 140 deep overhang, then you would use the 140 fascia, and it's put on the flat side of the cord, and the idea is that it forms a vertical face for the fascia to be fixed onto, just like that. Okay. This is a USB 89 by 1.2 cleat. It's for fixing the barge board in place. So the way you would apply it is where the purlins end over the gable wall, then this gets put generally underneath like that, 2 screws in there, one over there and one over there, and then that forms a flat surface onto which your barge board can be screwed. 2 screws into the side flange of your cord. Here we have a USPF 89 by 1.2. This is quite an unusual one. If you've got a long overhang of your purlins off the end of the last truss, and you want to secure the fascia a little bit better. The fascia is normally fixed to all of the fascia cleats, but right out at the end in the corner of the building you might have a situation where the fascia has got a 700 millimeter cantilevered section, and then it's possible to fix your last purlin onto this cleat and then fix your fascia to the other side of this cleat just to stabilize the fascia. Good. This is our steel purlin, USP 0.5. Its width is 80 millimeters, its depth is 40 millimeters, and the thickness is 0.5 millimeters. And as you can see, it's in the shape of a hat channel, and we generally use it for purlins, but we also use it quite a lot in cross bracing and runners. This is our steel batten, otherwise coded as US bat, and it is 20 millimeters high only compared to the purlin, which is 40 millimeters high. This is for taking tiles over 800 millimeter spacing of trusses, and it's also 0.5 millimeter material made from full hard steel. The standard length on the purlin is 5.8 meters, although you can order less or longer. The standard length on the batten is either 4.8 or 6.3 meters, but again we're flexible, we can roll it to any length that's required. Welcome to Alright, this truss has got a true span up in the top of the drawing that is 6180 meters. So now the first thing that we do is we shoot a chalk line across the base of our jig, which must be at least 6180 meters. We get it symmetrically in the middle, we establish exactly where the middle point of that is, and then we can draw the next lines after that. Hi. Yeah, that's good, that's good. Alright. Yeah, I have 1385, 13. Yeah, we're just going to miss both. Okay. 1385. Okay. Okay, now we've established the baseline in chalk. We've also got the middle of the chalk line. We've got the a point that is at right angles to the chalk line up at the top there. And now we're going to be measuring off the height of the truss. Okay, so from the book we can see that the top of the steel is at a height of 1868 millimeters. So that's what we've measured out at right angles to the chalk line, starting in the center bottom and coming up at 90 degrees. We can now put a line across the top of the steel and we can get the outline of the truss.
Okay.
Okay, the next two things to do are measure from the center of the truss out to where the end of the span reaches over here. So it's exactly half of that true span shown in the book. That's the first thing. And then the second thing to do is from that point on the chalk line, measure vertically upwards to get the top of the heel height. And that's also given in your cutting ball. Okay.
The angle of this degrees of this truss?
I think it's 26, eh? 26. So you can shoot a chalk line to the top there. Okay. We've now got a chalk line outlining the bottom of the bottom chord as well as the top of the top chords on both sides. What we're now doing is we're nailing blocks along that just to make sure that the steel stays within that. Alright, what we do now is we use the cutting bill to actually lay out the members of the truss. So the cutting bill has got a number of joints that are numbered on the page, and at the bottom of the cutting bill each piece is numbered. So you've got a TC, which stands for top chord, and then it gives the joint that that member runs from and to. So for example here it goes from joint 1 to joint 4 and joint 4 to joint 7, and it gives the exact length of that, and we're going to be putting that on the truss in position from joint 1 to joint 4 and moving through this whole length of material here, which will give us our first truss. Okay, the first thing we're going to do of the steel is build the bottom chord. This one has got a splice, so we're going to first put the splice in, then we're going to put the joiners at both ends, and that will complete the full length of the bottom chord, and we'll put that in the jig and then we'll proceed from there.
Where does this point?
It doesn't matter right now because we're just going to splice it. So put it against the wood down there so that it's just got a stable point at this one end like that. Okay, and bring this here. Alright. And then this splice goes this way around with a flat piece of the member against this flat piece here. Okay. And it's a 600 splice, so you actually mark it in the middle and then make sure that the middle of it sits in the middle of that splice. And then what you need to do is you need to line up the bottom part, this part of the steel here, because this part is a lip and it can move in and out, so that might not be aligned, but the bottom part down there must be aligned.
Yeah.
Okay. Mark 300. Okay, that's good. Alright. Okay, so we can put that like that, and then make sure that that's held down like that. Okay, this has got to all be straight. Okay, now this doesn't tuck in flat like that.
Okay.
It actually protrudes upwards,
okay,
so that you've got flat on flat.
Okay.
And that's not that relevant on the small member, but when you get to the bigger members, then it's really relevant.
Okay.
Okay. Alright, so hold that in position, put your foot on that side, and then we can look in the book to see how many screws we need for that. And on this case, there's 4 screws on either side of the splice. The numbers in the circles here are actually the numbers of screws that you need.
Right.
So we need 4 on this side and 4 on that side. Okay. Alright, now having seen from the cutting bill that 4 screws are needed either side of the splice, there's an exact limit on where the screws go. So if you've got 4 screws, then you would like to spread the 4 screws out as much as possible on the splice. So you would have 2, for example, over here and another 2 over here, because this splice member also has to transmit moment. So the further apart the 2 screws on either side of the splice are, the better. The next 2 rules that you have to comply with is that none of the screws may be closer than 12 millimeters to the edge of any steel, including the steel of the edge of the splice and the steel of the main member underneath this. So that's why I've moved these 2 in a little bit. And then the last rule you need to comply with is that the screws themselves may not be closer than 20 millimeters center to center. What we're doing now is we're completing the tie beam. So there's a splice in the middle of the tie beam, and then the next step is to put the joiners at each end of the tie beam. The size of the joiners is given specifically in the book, and also the extension past the end of the bottom chord is given. So in this case it's 61 millimeters. So this joiner then must stick out 61 millimeters off the end of the tie beam. It's generally symmetrical, so the other end will also stick out 61 millimeters. So that's the next step to fix this joiner in place on the bottom chord. Just to remind you that in the book, the numbers in the circles on the trusses denotes the number of screws at that particular joint. This. All right. 61 millimeters, so that must come to there. Okay, and then this goes in here like that. And then what we need, you see this goes fixed against the bottom chord like that. And then we need 5 screws in there. Okay, and the positions of those screws, again you've got your edge of your bottom steel, you've got the edge of this steel here, and you've got the edge of the flat steel.
Yeah.
So within that area, we have to put these things. Now you can't go within 12 mils at the end, so that you've got to come back about 12 mils there, you've got to come back 12 mils over here, and then we need to put 5. So the best pattern will be 1, 2, 1 in the middle, and 2 at the outer extremity of this side.
Yeah.
Like that. All right, put him down there. Now, the way this goes is that the steel here comes underneath this one there, like that, okay? All right, it's important when you're putting your top cord down that it must touch the bottom cord. So underneath here, these two members must touch, and that's one of the layout points of the truss. The same on the symmetrical other end over there, okay? Positioning the top cords at the center here, we've established the center line, and we've established where the top of the steel runs, which is along this wood. So now we just position these two members of steel symmetrically at that point, and then they're in position. All right, now we're positioning the top cords. So we've established where the top of them must be, and we've got the center line of the truss. And then the two of these members are going to be sitting symmetrically, meeting on the center line and meeting each other exactly symmetrically. Then this plate, the size of which is shown on the cutting bill, goes underneath the steel like this. You just mind your hand there. Okay. And then that is positioned with screws temporarily, one on each side. And then we can carry on from there. Okay. Now this is the 200 millimeter joiner that joins the top of this together. According to the cutting bill, we need 5 screws joining this top rafter to the gusset, and 5 screws joining this rafter to the gusset, as well as 2 screws joining the webs to the gusset, 2 screws to each web. And the first thing to do is just to put an initial placing screw over here and over here, and then we can get the outside of the truss fixed in position, and then we can start placing the webs inside. Now, in addition to the joiner plate down at the heels, we've got a little stiffener plate, which is made up of an 80 millimeter long piece of web, USW 76. And then this gets positioned as well over the support as possible. It does make it a little tricky to get the screws into the top cord, because on the cutting bill here, it's calling for 7 screws between the top cord and the gusset, with this web now getting in the way as a stiffener plate. So we're going to put 2 underneath the web. So we've positioned these carefully underneath the rib of the web. Those will be 2 of our 7 screws, and then we'll position the others shortly. In addition to the screws that are joining the gusset to the top cord, which in this case is 7, 1, 2, 2 underneath here, and another 3 here, that gives you 7. This stiffener plate needs to have 4 screws pretty much in its corners. So that's why these 2 additional screws are here, just to keep the stiffener plate in place. What we're now going to do is put the webs in position. So in order to do that, we can measure from the center point of the bottom cord out to the position of the bottom of each web. It's not necessary to position the top and the bottom cord exactly, because they only fit in one place. But it is necessary to position at least one end of a web in its correct position. So that's what we're doing now. Okay, and now the long web runs from the mark we've just made up to the apex. One down to the left. Get the other long web there. That's right. It must go down to that mark over there, yeah. And then that one starts at the apex and comes down to this mark over here. That's it, yeah. Now this mark, and this mark is the center of this joint. So in other words, if there's 2 webs coming in, then the mark that we've made is in between those 2 webs. So, and that is symmetrical at the top there. Yeah, that's fine. Okay, and if the webs don't fit, then you've made a mistake somewhere. You've either laid out the jig wrong, or you've cut the length of the webs wrong, or you've got something that it's gone wrong. Let's put this other web in place as well. And okay, we're just positioning this like this, but no, it's not necessarily. It's where it fits, in fact. But there's often two positions where it'll fit. One is like that and one is like that. So you've got to look at the configuration in the book to see which it is. When you're putting a web in place, it's best to position it and then to put one screw at each end and then complete the screws at any one end, just to position that end so that it doesn't move around while you're doing this end. Long stuk opgesny. Maar jy vat dan 5 truss and there's 10 trusses, so it's 20 altogether. Okay, go. All right, now swing it up. Okay. All right, now having constructed your truss thus far, you'll see that you've now got a gap in the top of the truss. Now, we've developed a new product since the forming of the old one, so you'll see we're in a different setting here. We're actually in the pub at Mitek, and I want to show you the new product that we use. We use what is